So remember everybody, when a rod is free to deform in any direction, so the change in length, if you want to calculate it, then that is what delta L is equals to original length into alpha into delta T. That is what change in temperature. So now, if for example, not free to deform means in the sense of the rod is attached between two kinds of rigid surfaces. For example, let me take, this is a rigid surface and this is the another rigid surface. Now, the rod is fixed between them. Now, if you have noticed it, if I start heating during this time, so is it free ends are there to expand or it is a compressed one, everybody? So now you tell me, is it any possibility of expansion of this rod if I are heating? Anyone? Yes, please. No. Am I right or wrong? So by the time what will happen? The walls of this one will exert the force on into the rod. That is what? If you try to expand it, there is no possibility because it is a rigid surfaces. It is attached to it between them. So let me take this rod, area of cross section is A, length is L, Young's modulus is alpha, and as well as, sorry, Young's modulus, what is that call it as? Name, I forgot it. Gamma, correct? So Young's modulus and as well as alpha. So now, as we know that if the rod is between, it's been like controlled, it is completely packed between the two rigid surfaces, it cannot extend any direction. So that by the time what will happen, because the rods are exerting pressure, the fixed walls are exerting pressure on this rod. So what will happen during this time? Not extension stress. It will be having a what stress actually? It will be having a compressive stress. Imagine that you are being pressed between two fellows. How it will be? You will feel compression. So that is what is the compressive stress will take place. So now, during this time also length will deform. That is what original length will changes. So original length may increases or decreases. But if it is a compressive means, length will decrease or increase. Everybody, temperature rises. Temperature rise, length will decrease or increase. If it is compressed, so what will happen? All of you. Length will decrease. So let me take the new length is, of course, it is a negative or positive. We'll take it as a L plus delta L. So delta L means it may be decreased or increased, doesn't matter. So we'll take it as a L plus. So delta L means just now we have been got the formula. What is delta L? Delta L means what? L into alpha into delta T. So that is the actually the true length. If it is free end, if it is the free end, this is the actually the true length of the rod. But because of compression, so what will happen? The pressure will increases in the rod. It is no free ends to move freely any side. So what is happening? Inside the stress is increasing. That is the stress we used to call it as a compressive stress as the force is exerting on a unit area. So now what will happen? If because of heating it is exerting, so stress is increasing means automatically the strain also will increases. So strain is equals to change in length divided by original length. So but this length is happening because this strain is because of what? Compression or expansion or everybody?
Compression.
Compressive. So as it is because of compressive stress, compressive strain is exerting due to the heating, due to heat. That is why this strain is called it as a thermal strain we used to call. So thermal strain is equals to delta L divided by L, which we used to call it as a compressive strain or compressive stress. Because of compressive stress, it is happening. So we all know Young's modulus is equals to stress divided by strain. So from that I will write stress is equals to everybody Young's modulus into what I can write strain. So now from that I will replace that delta L by L with that. So thermal stress which is equals to what I can write everyone Young's modulus into we all knows that delta L by L. So now we all just now we have derived it delta L is equals to what is the formula? L into respond L into alpha into change in temperature divided by original length. So I will write that one. So what will everybody, sorry, yeah, original. So now I will replace this delta L with that. So Young's modulus is equals to alpha means what? Sorry, delta L means what? original length into alpha into change in temperature divided by L. So LL will get cancelled. So we'll get thermal stress is equals to, what is the formula, everybody? If it is not free ends are there, Young's modulus into alpha into delta T. So this is the formula for thermal stress. So please all of you write it. Any doubt, anybody can ask me. Okay. So now we all knows that stress is equals to, what is the formula, guys? Stress is equals to, what is the formula? Stress is equals to, what is the formula? Pradosh? Force by area. So from that, force is equals to, what is the formula? Stress into area. So now the stress means what stress? Thermal stress. So if you write it, the thermal stress is equals to, if you make it, so what is the answer will come, everybody? Thermal stress is equals to Y into, that's what, Young's modulus into alpha into delta T and into area. So this is the formula for calculating the stress. So please write it, stress or thermal stress if you have taken. So strain is equals to, we got the formula, thermal strain is equals to delta L by L. And we all knows that Young's modulus is equals to stress by strain. So from that, stress is equals to Young's modulus into strain. So what is strain? Strain means what? Delta L by L. So I just replace it. Is it okay, brothers? Mr. Narayan, understanding? So that is what is the thermal strain. So what is thermal stress is equals to? We all know delta L means what? Delta L is equals to original length into alpha into delta T. I replace that and LL will get cancelled. I'll get the thermal stress is equals to Young's modulus into alpha into delta T. So or else we'll get it again, stress is equals to force by area. If I substitute it, force is equals to, what is the formula, everybody? The force F is equals to, we got it, Young's modulus into alpha into delta T into A. This is what is the force formula. This is the thermal stress formula. And this is the thermal strain formula. So please note it, everybody. So very, very important. So if you remember only single formula, what is that? Delta L is equals to L into thermal coefficient alpha into change in temperature. If you remember this, remaining all the formulas are very simple. That is what strain or thermal strain is equals to delta L by L, which is equals to L into alpha into delta T divided by L. So LL will get cancelled. What is the thermal strain formula? Thermal strain is equals to alpha into, speak guys, alpha into delta T. Understand, Amma? Now, if I substitute in the stress, so stress is equals to, we all knows the formula. What is that? Young's modulus into strain. So that is the formula. So Young's modulus into alpha into delta T. That is what is the stress. So from that, force is equals to, what is the formula? Everybody, stress into area. So stress is equals to Young's modulus into alpha into delta T into area A. So this is what, just by remembering the delta L, please remember, we can write all the strain formula, stress formula and force formula. Thermal strain, thermal stress and force. So I hope you all clear. So this is what is the formula for calculating thermal strain and thermal stress and all. So now based upon this, we can solve one question and then we'll go to the next Poisson's ratio. So now, but before going to teach the Poisson's ratios and all, so let us solve this question and we'll move further. Okay, so I'll make the question, everybody. I will understand, everybody, what is thermal stress and what is thermal strain and all? Yes. So now write it. A steel rod of length 6 meter, a steel rod of length 6 meters. Prados, can you hear me? 6 meter and diameter 20 mm is fixed as shown. Is fixed as shown means in the sense of fixed between the two walls. So what is that? Diameter and length is given. So fixed between the two walls. If the temperature rises by 80 degrees Celsius, find the stress in the rod. And Young's modulus is equals to 2 into 2 power 6 kilogram per cubic centimeter square, and alpha is equals to 12 into 10 power minus 6, okay, per degree Celsius. and per centimeter. This is what is the alpha. So degree centimeter, degree Celsius per degree centimeter. So now let us solve this one. So if it is allowed to yield expand, okay. So what is the, so this is what, so find the answer everybody. So how much is that? That is what they are asking. So change in temperature, delta T is equals to, how much is the answer? 80 degrees Celsius, and delta L is equals to L into alpha into delta T. So if I substitute, what is the strain formula? Make it quick everybody. Strain is equals to delta L by L. So which is equals to what, all of you? We got it. Delta L means what? L into alpha into delta T divided by L. So LL will get cancelled, will get alpha into delta T. So what is the alpha value? Verify it everyone. Alpha value. Yes, please. 12 into 10 power minus 6. Am I right? Please respond. Into 10 power, the temperature means 80 degrees. So now we want it to strain. They are asking stress. Yeah, stress. So stress is equals to what? Young's modulus into strain. So now, which is equals to Young's modulus value, how much am I? 2 into 10 power 6, okay, kilogram per cubic centimeter into strain is equals to 12 into 10 power minus 6 into 80. So this is what it is. So now 10 power minus 6, 10 power 6 will get cancelled or not? Verify it everybody. Yes, please. 10 power 6 and 10 power minus 6 will get cancelled. So what is the answer remaining? 2 into 12 into 80 over. So 2 into 12. 12 2s are 24. So 24 into 80. So how much is the answer? Anybody? Yes, please. 24 80s are. What is the answer, ma? 24 into 80. How much? 1920. 1920 kilogram per cubic centimeter square. That is what is the stress. Note it everybody. Anything doubt you can ask. Clear? Rudreswa?
Yes, sir.
Yeah.
Do it everybody. What do you mean by stress? Stress is equals to force per area. So that is what? Force is equals to, what is the units? Newton per square meter. Newton is equals to kilogram meter per second square per, here also meter square. So the units you have to write it. Kilogram will be there. Meter and meter will get cancelled. So units are wrong. You have to write the units. Write it correctly. What is the units will come? You have to make it. So what is the units will come? Stress is equals to, centimeter is given. So kilogram, centimeter, and temperature is also there, correct? Okay. So that is the answer, 1920. 1920 is the answer. So now the next question is, my units you write stress unit kilogram per cubic centimeter. Okay. Cubic centimeter. Write it that. Now, if it is allowed to expand by 1 centimeter, sorry, 1 millimeter. Next, second part. If it is allowed to yield, if it is allowed to yield, expand by 1 millimeter, then what is the stress? Either it is the same, or it will be increases, or it will be decreases. That is what is our target. So let us see now. So what is that? How much it is increases, everybody? Change in length. If it is allowed to expand by how much it is? Just how many millimeters, everybody? Please respond. 1 millimeter. Do you understand, Amma? So 1 millimeter. So how much is the stress they are asking? So first let us find the strain now. So strain is equals to, all of you remember formula. What is the strain formula? Anybody? Delta L divided by L. So now how much it is allowed to expand? How much it is allowed to expand? 1 mm. Understand? Divided by original length. So now you can write the formula and you can substitute it. Everybody. So stress is equals to Young's modulus into strain. So I'll write it now. So Young's modulus into strain is equals to delta L minus 1 mm divided by original length. So I'll modify everything into centimeter. Young's modulus is equals to 2 into 10 power 6. Delta L means L into alpha into delta T minus 1 mm divided by L. So I will write it 2 into 10 power 6 into this one. If I cancel it LL, I will get alpha into delta T minus 1 mm divided by L. Any problem for anybody? You can ask me. Okay, clear understanding everybody? So 2 into 10 power 6 into alpha value how much ra? 12 into 10 power minus 6 into change in temperature 80 minus 1 millimeter. So 1 millimeter means how many centimeters? 0.1 centimeter divided by original length is equals to how many original length amma? 6 meters. So 6 meters means how many centimeters? 6 meters means how many centimeters, guys? 600 centimeters. Now, so 2 into 10 power 6 into, so this one 12 into 10 power minus 6 into 80 minus 0.1 divided by 600. Okay. So now I will write this one as, you can see, can I write this one as 1 divided by 6,000? Any problem for anybody? 1 divided by 6,000. Okay, wa? Please respond. Any problem? Yes. So now you can do it, everybody. This one will turn up into multiply with everything. 2 into 12. So you can see 10 power, it will come like a 2 into 10 power 6 into 12 into 10 power minus 6 into 80. So minus of 2 into 10 power 6 divided by 6,000. Now 10 power minus 6, 6 will get cancelled. 12 2s are 24, 24 into 80. Just now we have done, which is equals to 1920. Now here 3 zeros get cancelled. Here 3 will be remaining. 2 ones are, 2 threes are. So 3, 10 power 3 is remaining, means 1000 divided by 3. So which is equals to 1920 minus 1000 divided by 3, which is equals to 333.33. So if I subtract it, or you can do that normally, which is equals to answer, how much it will come? Kilogram per cubic centimeter. So which is equals to approximately 1857 kilogram per cubic centimeter. When it is just allowed to expand, how many millimeters? Everybody, how many millimeters? Millimeter. If you just allowed to expand 1 millimeter, stress is decreasing or increasing? Everybody, stress is decreasing. Okay, so that is what you have to remember it. So this is how we have to calculate what is the stress in the body, and if the length is expands or if it is decreases. So remember, expands means -1. If it is allowed to compress 1 mm, +1 will come. So we have to make it decreasing means plus, increasing means minus. That is what we will say, like delta L will come. So change in the length. So that is what you have to remember, and you have to solve the questions like this only. So then tomorrow's class we'll see Poisson's ratio, and then as well as change in density of a fluid, how these two concepts are varying. So if that is over, then the chapter over, then tomorrow itself, if possible, we'll start mechanical properties of liquids. I hope you all understand. Anybody having any doubt, you can ask me, or else we can stop here and we'll continue in the tomorrow's class. Are you clear, everyone? Yes, please. All of you?
Sir.
Yeah. So please try to spend time and wake up, at least take seriously. Already term 1 over, term 2 is going to start, and November is also ends. So when the days will over, when you will come to the 12th class, we don't know. So make it and speed up, wake up early morning and work out. This is what I can say. So this is all about the today's class. If you all understand, you can leave from the meeting. Thank you, everybody. We'll meet in tomorrow's class.